This next video for chapter 6 is putting all the transformations together. So the first thing I want to talk about is a summary of transformations. What does A do? What does B do? What does C do? What does D do? So what's the actual transformation? And then what does it affect on the graph? So let's start with A. So the A value is a transformation on X or Y. So since it's not in the bracket with X, it's a transformation on Y. So what can it do to Y? Well, there's two things it can do. It can vertically stretch or shrink. And it can also, I'm going to try typing this time because my writing is so atrocious. Oops. There we go. It can also reflect the Y values over the X axis. So those are the two things that the A transformation can do. Now, if you have those two things, what feature on a sinusoidal graph is it going to affect? Well, the A transformation starts with A, so it also affects amplitude. So the A transformation is going to affect amplitude. How? Well, amplitude equals the absolute value of A. What else? Well, at this point, it can also affect the range. If you have an amplitude of A, so for a normal sinusoidal function, it goes from -1 to 1, but if you change that amplitude, then your range simply goes from -A to A. I'm going to change the color of that writing because I feel like that's really bright. That's better. Change this guy too. Okay, let's move on to the B transformation. So B is a transformation on X or Y? It's X because it's in the bracket with the X, or it's just with the X. So what can it do? Well, it horizontal, or I'll just put horizontal, stretch or shrink. And if it's negative, you can also reflect the X values over the Y axis. Okay, what features will it affect on the graph? Does it affect your amplitude? Nope. Does it affect your period? Yes. So your period, write it up here, your period equals, now this one I can't type in, so I'm going to switch back to my pen, is always 2 pi divided by the absolute value of B. Now, what else can it affect? Well, it definitely also affects your x-intercepts, but I've chosen in this course, and the textbook kind of chose for me, that we aren't going to be really doing much with x-intercepts. We will kind of look at them a little bit again in chapter 7, but only from that standpoint of understanding that, sine has x-intercepts every n pi, and cosine has x-intercepts every pi by 2 plus n pi. We aren't going to be transforming those. So we can move on to C. C, when we were in chapter 2, we called this a horizontal translation. When we move into sinusoidal functions, we call it a phase shift. So this is a phase shift, and it can go left or right. So what does it affect? Does it affect your amplitude? Nope. Does it affect your period? Nope. Does it affect your domain? Nope, nothing affects domain. Does it affect your range? Nope. Does it affect your x-intercepts? Sure. I mean, it does, but again, like I said, we're not going to really worry about that. What we are going to worry about is the fact that it affects your starting point. So if you think about a sine graph, right? A sine graph normally starts at 0, 0, and then goes through a cycle. If we have a phase shift, this starting point can go left, or your starting point can go right. If you're looking at a cosine curve, cosine starts at 1, right? 0, 1, and again, it can change that starting point left or right. The last transformation is D. D is considered, I'm just going to change back to my pen, a vertical, because again, it's not in the bracket with the C, so it's affecting Y, and so we call it a vertical translation. And that could be up or down. Now, what can it affect? Your amplitude? No, it doesn't change the size of how far up you go or how far down you go. What about your period? Nope. What about your domain, your range, your x-intercepts? I mean, it's definitely going to change your x-intercepts, so we could put that in. But most importantly, it's going to affect your range. How is it going to affect your range? Well, let's look at an example of a graph. So if I give a graph that's been moved up, so it doesn't matter what graph, let's take a cosine graph and move it up. My question is, how does the d value affect your range? Well, first of all, it affects your center line. So I should start with that. So the first thing it affects is your center line. Your center line will be at y equals d. So then for your range, how does it affect the range? Well, if your center line's d, how am I going to show this? Let's just go back to the pen. So if my center line is here at d, you can go up your amplitude and you can go down your amplitude from there. So what I would say is that to talk about range, we talk about it in relationship to that center line. So your minimum point is going to be from your center line down your amplitude, so d minus a, and then your maximum point is going to be from your center line up, so d plus a. And that is going to be the range of your graph. So now that we know how everything affects your graph, or what it affects, now let's look at some actual graphs. Oh, and we also talked about adding, it does affect your x-intercepts, but again, we're not going to really worry about that, so I should put that in there. X-intercepts. Okay, so how do we use this information to make a graph? Well, the first thing I'm going to graph is y equals 3 sine of x minus a quarter. So before we go into any of the graphing, can you describe the transformations to me? So if you look at it, we always go from left to right. So what is this 3 going to do? Well, the 3 is a vertical stretch. What about this minus pi by 4? Well, that's your c value. So it's going to be a phase shift. Which direction? X is always opposite it appears. So it's going to be a phase shift right pi by 4. And this one I should put a vertical stretch by 3. So some people actually don't even do what I'm about to do on the left-hand side. So one thing I'm going to show you, let's go to Desmos for a second. So all I want to show you is that these transformations in order from left to right, the first thing we're going to do is y equals sine x. So this is my y equals sine x curve. It's got a starting point at 0, 0, and then every pi by 2 you have your key point. So at pi by 2 we go up to 1, at pi back to the midline, at 3 pi by 2 down to -1, and then back up to 0 at 2 pi. So if we put the 3 in there, so if we talk about the first transformation being a vertical stretch by 3, you can take that y equals sine x graph and simply stretch it by 3. So now instead of having a graph that only goes up to 1 and down to -1, now my graph goes up to 3 and down to -3. And then the last transformation is just a phase shift to the right pi by 4, which would be y equals 3 sine bracket x minus pi by 4 unbracket. And I just take that blue graph and I move it for, in my case, it's what, 4 grid lines? So, or 1 major grid line? 1 major grid line to the right, and I take every point in that graph and I move it. So one way of doing these transformations is you don't have to know key points and all that kind of stuff beyond your basic graph. It's just taking your graph and transforming it one step at a time to come up with your final graph. Alternatively, we can think about the features of this graph and graph it in a cyclical nature. To do that, I mean, the first thing you need to do for either one actually is know the scale. So if you look at this grid, it takes 1, 2, 3, 4 grid lines to get to pi. So the scale of my graph is going to be pi by 4. Then what is the amplitude? Well, the amplitude of my equation is 3 because the amplitude is always the absolute value of a. Your period is 2 pi by the absolute value of b. So it's going to be 2 pi divided by 1, because there's a b value of 1 in there. So my period's just 2 pi. So where are my key points going to happen? Well, key points are your period, sorry, not key points, are divided by 4. So 2 pi divided by 4 keeps those key points every pi by 2. This is just your basic sinusoidal graph. How many grid lines is pi by 2 worth down here? Well, my scale is pi by 4, so it's 2 grid lines, or you can just be like halfway to pi is 2 grid lines. So it's going to have key points every 2 grid lines. What about the phase shift? Well, the phase shift we know is going to be right pi by 4. on this grid that I chose, pi by 4 is one grid line. What about vertical displacement? Is there a d value? Nope. What's the domain of this graph going to be? Well, negative infinity to infinity. It's always that. It's never going to change. And what about the range? So the range, remember, goes from your center line up your amplitude, and from your center line down your amplitude. So it should have been a minus sign. So if my center line is at 0, I'm going to go up 3, and I'm going to go down 3 from 0. So my range is going to be negative 3 to 3. So how do I take this and translate it onto the grid? So if you don't want to do your transformations off of a base graph, you're going to use this information, and the key next part is where you're starting. So now I can look at the fact that this is sine. So normally I start at 0, 0. So here's my 0, 0. Except this graph is getting shifted to the right pi by 4, or one grid line. So now instead of starting at 0, 0, I'm going to start at pi by 4, 0. Then I know that every 2 grid lines, I'm going to have a key point. And that next key point, so from 0, 0, sine goes up. So you can think of your basic sine graph. So normally from that starting point, you go up. And so I'm going to go up. So in 2 grid lines, 1, 2, I'm going to go up to what? Well, I'm going to go up to 3. So normally we go up to 1, but I'm vertically stretching it by a factor of 3. So I'm assuming my scale on my y-axis is 1. Then in another 2 grid lines, I'm going to go down to 0. In another 2 grid lines, I'm going to go down to negative 3. In another 2 grid lines, back up to 0. In another 2 grid lines, up to 3. In another 2 grid lines, back to 0. And then down to negative 3. And I can go in the negative direction as well. So 2 grid lines down to negative 3. 2 grid lines back up to 0. And now I can sketch my curve. So it's going to start like this. Fun is that? So I've done it using the cyclical nature of a sinusoidal function. The fact that these things, you get these key points that happen at very regular intervals. So if I know how many grid lines that regular interval is, it makes it pretty easy to sketch this curve. And that's it. So now if I wanted to compare this to the one that I got in Desmos, right, you can look at it and see it. So here it's starting one grid line over, one grid line over. And then just before pi, it's got its first peak at 3. And so I did the same work. So whether you want to start with your base sine graph and then stretch it and move it right, or whether you want to say, hey, where does a sine graph start? And then where would my next key point be? You're good to go. So now what I would like you to do is try this one. So the first thing I would recommend you doing is I want to see if you can fill out this left-hand side. So without knowing this is cos or anything, can you figure out amplitude, period, key points, phase shift, vertical displacement, domain, and range? So I want you to pause the video, and then when you feel like you've got this left column filled out as much as you can, unpause the video. And then you'll pause the video again and try the graph. So just making sure that you're on the right track. Okay, so going through this, hopefully you did pause the video. First thing we want to figure out is what the scale of this grid is, just knowing what you're working with. Well, it's 4 grid lines to 2 pi, so halfway to 2 pi is pi, and then halfway to pi is pi by 2. So each grid line in my x-axis is worth pi by 2. Amplitude of this graph, there's a 1 in front of the cos, so it's going to have an amplitude of 1. Period. Now, period's 2 pi by b, and in this case, my b value is a quarter. So if you're very stuck on the formulas, you're going to be like, to find the period, I do 2 pi divided by the absolute value of b. And then you'd have to go 2 pi divided by a quarter is the same as timesing by 4 over 1, right? Flip and multiply. And I get my period as 8 pi. Or simply, you could say my period's normally 2 pi. This graph has a horizontal stretch by a factor of 4, so I know just to multiply my period by 4 and get 8 pi. Now key points is your new period divided by 4. So 8, sorry, I'm losing my voice. 8 pi divided by 4 is 2 pi. So I know to get to 8 pi in a regular cyclical manner, every key point is going to happen at 2 pi. How many grid lines is 2 pi? Well, looking on here, it's clearly labeled. So 4 grid lines is 2 pi. Is there a phase shift? Nope. So I don't care about those two. Is there a vertical displacement? Yep, I'm going up 3. The domain of this graph is negative infinity to infinity. That's never going to change. And the range is d plus a and d minus a. So my center line is 3. I'm going to go up 1, and I'm going to go down 1 from there. So I'm going to go from 2 to 4. All right, so those are all your features. So now pause your video, see if you can now figure out how to make this graph. So for me, I know I'm looking at a cosine graph that's been moved up 3. So the amplitude isn't changing. So normally I would start at 1, but instead of starting at 1, I'm moving that up 3. So 1, 2, 3. So this is actually going to be my top point of my cosine curve. Now, some people find it easier if you actually draw yourself a new center line. So instead of having the y or the x-axis to oscillate around, some people will draw themselves that new center line. So the new center line has been moved up 3, right? So now from here, I'm going to do my next key point. My next key point is, if you're thinking about a cosine curve, right? Cosine starts at the top, goes to the midline, and then down and back up. So I've done my top point. I need to figure out my midline. So in 4 grid lines, because every key point is going to happen in 4 grid lines. So 1, 2, 3, 4, back down to the midline. In another 4 grid lines, 1, 2, 3, 4, back down to the below the midline. 1, 2, 3, 4, back up to the midline, and 1, 2, 3, 4, back up. Now you can see here I've got one cycle of cosine. So if I connect my dots here, this is one complete cycle of cosine. And if I continued this scale, every 4 grid lines being 2 pi, I'd have 4, 1, 2, 3, 4, this would be 6 pi. 1, 2, 3, 4, that would be 8 pi. So I can see that one complete cycle happened in 8 pi. To finish off my grid, I go 1, 2, 3, 4 to the left and back down to the midline, just so I cover the grid. And again, it's going off and on in both directions, but if you reach the end, it's assumed to go on. And that's it. And again, you know, if you're not comfortable with doing it with key points and, you know, all of that stuff, feel free to just go from your base graph. So for this one, your base graph is cos x. There it is. Let's change the scale. The scale was negative 2 pi to 8 pi. So let's go, just so it looks like the one we just did, negative 2 pi to 8 pi. With a step of, what was it? I've forgotten already. Pi by 2? Doesn't really matter. Pi by 2, something like that. Okay, so here we go. This is the graph. This is the first one. So the next thing is that you've got a horizontal stretch by a factor of 4. I forgot to write that down. So cos of bracket 1/4 x. So this would be your first transformation, which is a hard one to do. I mean, but if you're looking at it, like there's my first point, and then pi by 2 gets stretched by 4 to go to 2 pi. This point here at pi gets stretched by 4 to go to 4 pi. So you can see that visual stretching in a horizontal direction. And then lastly, we move it up 3. So y equals the cos of 1/4 x plus 3. And then I've got that final graph, which should look like the graph that we did here. And it does, right? So one thing I should have written here, right? What are my transformations? Well, the first transformation is a horizontal stretch by 4. And secondly, it was a vertical translation up 3. Okay. Before we can stop this video, I realize this is turning into a long one. I just want to do a couple without graphing. So I want to figure out amplitude, period, phase shift, vertical displacement, domain, and range for a graph without having the graph. Okay. So the first thing I want you to notice is that there's something weird about how this equation is written. It's the reason I've picked these two. When we talk about transformations, it's always y equals a sine b bracket x minus c plus d. And sometimes you'll see square brackets put around this. What is the difference between this and this? Well, it's the difference between 3x plus pi versus 3 times x plus pi. When it's written as 3x plus pi, 3 is b for sure. But this is not c, okay? It has to be written like this, and here that would be b, and this would be c. But this one's not in factored form. So the first thing you're going to want to be able to do to see your phase shift is factor this bracket. So to factor it, you're always going to just take the coefficient on x. So I'm going to factor out 3 out of each of these terms, and I would be left with y equals 2 sine 3 times x plus pi by 3 minus 4. So now I can answer the questions. Amplitude is 2. Period is 2 pi divided by b, or 2 pi divided by 3. The phase shift is left pi by 3, right? And so the most common mistake is that people will say the phase shift is left pi. But if you do that, you will not get the right answer. Vertical displacement is down 4. Domain is negative infinity to infinity. And the range is vertical displacement up and down your amplitude. So your d is minus 4. You're going to go up 2 and down 2. So it goes down to negative 6 and up to negative 2. And that is everything. So now what I want you to do is try this one. Now I understand that I made this one more complicated. I put a fraction in there and I did it on purpose, right? But you're dividing each of these terms by a quarter. So alternatively, some people just go, hey, you know what? The phase shift is always what's written here. So I'll just call it C, but divided by B, right? So you're always dividing by the coefficient on X. And so if you're having a hard time doing pi by 2 divided by a quarter, write it down over here. Pi by 2 divided by a quarter, right? And then simplify. That would be pi by 2 times 4 over 1, which is 2 pi. Which means this in factored form would be y equals negative cos of a quarter times x minus 2 pi plus 5. Now I can answer the questions. Amplitude is the absolute value of A, so it's 1. Period is 2 pi by B, so 2 pi by a quarter. Or I can see that it's a horizontal stretch by 4, so that my period is 8 pi. My phase shift is right 2 pi. My vertical displacement is up 5. And my domain is negative infinity to infinity. And my range goes from 5, up 1, and down 1. It doesn't matter that it's been reflected. It's still just down 1 and up 1. So it's going to go from 4 to 6. All right, so that's the last part of graphing. Now, if you want to keep watching, I'm now going to show you that if I wanted to graph this one, I could. And I'll just show it, like, even though, like, I won't ask you to do this on a test. Usually I'll only put like max two transformations, but I want to show you that it's possible to do it even if there's, like, this one has 1, 2, 3, 4 transformations in it. So let's try it. So what I'm going to do is I'm going to put the final graph here. So I'm going to put y equals negative cos, and now I'm going to prove to you that we did it right. So I'm going to put a quarter x minus pi by 2. That's what I'm going to put into here, just because that's the original equation. So I'm going to make Desmos do that, but we are going to do it based off of what we discovered. So let's go like that. I'll just move this down a second. Okay, so what did we do? Well, on the previous page, we decided that, oh, wait a minute. How do I write on that? In Zoom, I can just write. One sec. There we go. Sorry, I just had to figure out how to do that. So we are actually going to be doing y equals negative cos of a quarter times x minus 2 pi plus 5. So how would we do this? Well, we know that the amplitude is 1. We know that the period is 8 pi. So now we know that our key points are going to be 8 pi divided by 4, so every 2 pi. We know that there is a phase shift, which is right 2 pi. And we know that we have a vertical displacement, which is up 5. So how am I going to graph this? Well, now I can look at the fact that this is a cos graph. So cosine normally starts at 1 and goes like this. Because there's this negative out front, I know it's a reflection of the y values over the x-axis. So instead, I'm going to think about my base graph as going like this. So what does that mean for me? Well, normally my graph would happen, or would start down here at negative 1. But I'm also going to move that up 5. So 1, 2, 3, 4, 5. So this is where my graph would normally start. But I'm going to make the starting point happen right 2 pi. So I'm going to go over here. Oh, and look at that. There's a point that matches. Then I have to figure out where my next point is going to be. So my key points are every 2 pi, which on this scale is 1, 2, 3, 4 major grid lines, right? So now every 4 major grid lines, I'm going to do another key point. So this time I know I'm starting at the bottom. So now I have to go up to my center line. And again, if it helps, feel free to draw the center line on. So I know that up 5 is going to make a center line across here. Okay, so now if I'm going from the bottom, in 4 major grid lines, I'm going to go up to midline. 1, 2, 3, 4, here we go. 1, 2, 3, 4, up to 1, 1, 2, 3, 4, and back down. So the moral of the story is, I made Desmos graph the entire thing, but then I was also able to build it from scratch. Have fun.